Hello there, Math 126 fans. Going to talk about paraboloids. I'm going to split this up and just talk about each shape. Watch my previous video where I talk about the different types of shapes you can get. This would be any situation where you have an equation where one of the variables is not squared and the other two are. Now there's two flavors, but I'll say a few general things first. The key is that if both of these are positive, it's a circular or elliptic paraboloid. And if one of them is negative, it's a hyperbolic. But the way the book often writes it is you'll see it write it this way. So a few little technical notes. This is just a fancy way for the book to say, assume I have a positive number. And you can interpret that as a scaling factor. Whether we write it this way or that way, it doesn't matter. Now, their A and B mean something different than mine. That's kind of immaterial. When it comes to naming something, though, if I write z, let me get a better color. If I write z equals, and let's just throw some numbers in. So let's have it be 2x squared plus 3y squared. I already talked in my previous video how to name that, but I'm going to show you some cool visuals here in a second. We look at traces. We say if we fix x to be a given number, or if we cover it up, what are we left with? We're left with z equals a number plus 3y squared. That's a parabola. You can see that right away when you cover up y. And what that means is when you're fixing x, you're actually looking at a parabola. You're looking at this parabola. And I'll show you that in the 3D visual in just a second. If you fix y, you get z equals 2x squared plus whatever y is. That's a parabola. And if you fix z, what do you get? You get some number here, 2x squared plus 3y squared. It's an ellipse. It makes it easier to remember the name. Elliptical paraboloid. Paraboloid means two of the traces are this. One of the traces is an ellipse. So let's see. It's kind of fun to put them side by side. You can see it in my 3D picture here. But let's get rid of the second one. And let's show you the traces. This is just a random one. Again, if you change the numbers A and B, it just changes the ellipse. So there you go. And you have access to this. You can play around with this all you want. Oops, I bumped something I didn't mean to. That's for later. That's it. So just makes an ellipse. Note that the ellipse is around the z-axis. So one comment is, what if you change the order and it's y equals x squared plus z squared? Well, then it will be around the y-axis. That's another reason the traces help me, because that's what's saying is for a fixed z, that's where the ellipse is. Now for a fixed y, you'd have an ellipse. I can show you that real quick. If I just switch the roles here, so I'm going to graph y equals x to the second plus z to the second. See, paraboloid just pointing off that way. No big deal. So the key is that two are squared and one is not. The other key is that it's just these traces. Now I'm going to show you the traces for a fixed x. So I'm going to show you, there's when x is fixed, there's a plane, and here is the trace. We'll do a lot of this in chapter 14, but you can see they're all parabolas. Let's let x move. No matter what x is, it's a parabola. That's like looking at it from the side, sort of looking at the shadow, so to speak. We'll use this later, like I said in chapter 14, to study this. So from the x's perspective, it's a parabola. All right, let's play that game again. Let's get rid of those. Now let's do it from the y's perspective. So from y's perspective, also parabolas. That's it. And then from above, let's get rid of that. Let's look at it from above. And let's animate that. Here we go. Oops, I don't need to go down. There is no negative. There's nothing down there. Let's go here. An ellipse or circle, depending on what my numbers are. That's it. So it's a circular or an elliptical paraboloid. Paraboloid means parabola in two directions. Okay, so there's another possibility, which is that you could have a minus between them. So let's just make up an example. Let's say 3x squared minus y squared. So now what happens when you look at the traces? If you fix an x, you get z equals blank minus y squared. And I know I'm running into my picture here. And that's a parabola. It's a sad parabola, but it's still a parabola. It opens downward. Let me get my correct color here. If you fix y, what do you get? You get z equals 3x squared minus a number. It's a parabola. It's a happy parabola. And when you fix z, you get something equals 3x squared minus y squared. That's a hyperbola. There's a technicality that if this is 0, it's actually 2 lines, but it's a hyperbola for everything else. We call that a hyperbolic paraboloid. You can see it in the picture that there's a parabola in one direction that goes up. There's a parabola the other way that goes down. And from above, it looks like a hyperbola. So let's show you some pictures of that in an example. And then I'll talk about some interesting application stuff. There's too many things to say here. It's actually really interesting, but let's just focus on this piece. So there it is. Let's look at the traces when I fix an x. So there's when I fix an x. And let's watch it go. Here we go. They're parabolas. Sad parabolas when you fix an x. Those are those cross sections. That's all we're really doing. It's like we're an architect looking at it from different sides. Let's now talk about if you look at the y cross sections. Y cross sections are parabolas as well. Happy parabolas, smiles, they go up. Last one, let's look at the traces. I keep trying to get rid of the wrong thing. Let's look at the traces from above. Now here you can see that actually that one's not 2 lines. It's very skinny parabolas. If you let z be 0, you actually get lines. Again, I save that technicality for later. So when you're on the ground, it's 2 lines. But above that, it's actually hyperbolas. Hyperbola is going up. Hyperbola is going down. Hyperbolic paraboloid. Why do we call it paraboloid? Because 2 of the traces are parabolas. So that's how I remember these names. Okay. Now, several little things. While I have my visuals up, I'm going to show you one more thing that I created that I'm proud of. And then I will talk about where these things come up in practice. So let's get rid of this. Let's get rid of that. Okay, quick little visual. I'll make this bigger so you can see it. So paraboloids come up all over the place when it comes to like satellite dishes and things. And I'll show you that in a second. But my favorite example of a hyperbolic paraboloid is a Pringles chip. And I found this online using dimensions that fit almost exactly a Pringles chip. That's what you get. So here's a Pringles chip cross sections. Those are parabolas, sad parabolas, opening downward. Here's a Pringles chip cross sections for y. There it is. Right there. And here's a Pringles chip like this. So I always think of a Pringles chip when I think of this. I don't know how to give it texture yet. That's for another day. I'll need to put that in something else to give it texture. All right. Let's finish this. I'm going to get rid of my visuals with a little discussion. So I've done a whole bunch of research. I found so many things, but I'm going to try to limit myself to this course. These are all examples of paraboloids. Paraboloids have this feature, that same thing a parabola has, which is there's this focus point. If you want to focus, if you're like building something, you want to make all the light go a certain direction, or if you want to focus everything that's coming in into a single point, like you're trying to get radio signals or something, they're valuable in that way. This is a solar cooker. So we focus all the light onto where it's cooking something. Your bulbs in your car have this feature because it makes it so when the light shines out, it bounces and the light goes straight forward instead of radiating out. If you take a cup of water and you swish the water around, you get this shape, paraboloid shape. But a lot of the facts boil down to this focus point of a parabola. It's just a 3D version of that. Okay, hyperbolic paraboloids have some interesting features. There's several places where they built the roof of some famous building using that style. Pringles Chip is mentioned, so I'm not the only person that's thought of. These are pictures I got from Wikipedia and other resources. Later, we'll talk about a saddle point. Now, a saddle point is a horse's saddle has this behavior right there. So that's kind of fun. But it has to do with the fact that it looks like a hyperbola. So this is what, from above, a hyperbolic paraboloid looks like this. From above, a circular paraboloid looks like a circle. But the rest of it is parabolas. Okay, hope that's interesting. Again, I have so many things I can say about this. I'm kind of noting them, but that's the basic idea. Two things are squared, one is not. Paraboloid.